Welcome. This is the final demonstration video of my project, the dual power supply. So this project is a linear adjustable dual voltage supply. I required a power supply to power my circuits, and I decided to build one from scratch for fun learning and also to customize it for my needs. The intention was to build a low noise power supply, so no switching voltage converters were used anywhere in the circuitry. And also the intention was for a reliable and well-protected power supply. So protection features include short circuit and overcurrent protection, overheat protection, and a limited negative current handling capability. So this is the user panel. These are the outputs. We have ground, positive and negative, and I decided to use these spring terminals because they are easy to plug any kind of wire into. Also, there's a female header outputs here. This is the output switch. So when it's on, the output is connected to the circuit, so it's powered, and when it's off, the output is disconnected from the circuit and instead is connected to the discharge switch. For more about discharge switch, please read the description. This is the display. For each terminal, the display shows 3 readings: the voltage, the output voltage, the output current, and the adjustable current limit. These two knobs adjust the voltage for each terminal between 0 and 15 volts, and these adjust the current limit between 100 milliamperes and 1.5 amperes. This is the main switch, so let's turn on the device and see how it works. So currently voltage and current are 0. I've inserted these pins into the terminals to test the device. I'm going to use this power resistor. It's 10 ohms. So let's bring the voltage up in both terminals. The current limit is now about 500 milliamperes, so I'm going to use probably 4 volts. So this is the positive side. Oh, it's off, so turn it on. So this is the positive side. Yep. And this is the negative side. Let's test the overcurrent. So I'm going to increase voltage to induce a current that is above the current limit and see how the circuit responds. So this is the positive, and this is the negative. Let's try higher voltage, higher current limit. Let's stay at 1, because 1.5 might not trigger current limit. So let's go for higher voltage here and here. This is the maximum. So this is the positive side, and this is the negative side. Yeah. Now I'm going to induce a direct short circuit using this piece of wire. This is the positive. This is the negative here. And now between the 2 terminals, positive and negative, and this is almost the worst case. Let's increase the current limit all the way to 1.5 amperes. So as you see, the device is really well protected. Also, the device, as I said, has a limited negative current handling capability. So I'm going to use this pack. This is a 4 battery pack. It provides 6 volts. The ground is already connected to the ground. I'm going to use it on the positive terminal. So I'm going to bring this voltage to below 6 volts, and let's see what happens. So you see there's a negative sign displayed in the current here to give a warning to the user that there's a negative current. Also, the device has a brightness setting here for the display. So using this button, we can cycle through the display brightness, and when it's left unchanged for about 10 seconds, the current brightness setting will be stored and used in the future when the device is turned on. I hope you like my project. If you have any questions, just leave me a comment and I will answer them as soon as I can. Thank you.